Hi guys. Now we have talked about capacitors, right? And we have done some basic concepts and figured out how to find effective capacitance for parallel circuits, series circuits, and so on. Right? Now I'm going to till now we've talked about capacitors where between the two capacitors there was no medium. It was we did not insert anything, right? It was just a, let's say, air or vacuum between them, right? Now let us say we want to we decide to we have a, let's say, two parallel plates and they form a capacitor, and we want to increase its capacitance. Right? Now, as we'll see later, one of the ways we can do that is if we put some non-conducting material between the two plates. Once again, if I have two parallel plates of a capacitor, if I put some non-conducting material, it turns out, we'll show you why in a short while, the capacitance goes up, right? So now that brings us to the idea of dielectric. A dielectric just means a non-conducting material, okay? The dielectric is a non-conducting material. Now, what's the difference between a conductor and non-conductor? A conductor, if you take a piece of metal, in conductor there are these free electrons. So let's say there is an atom, there will be one or two electrons, which are, let's say, not attached to that atom. They can move around, right? And that is what makes them conduct electricity. In dielectrics, all the electrons and the rest of the ion or the nucleus, they are tightly bound. The electrons are not, they're bound electrons. They're not free to move around, and that is why we call them dielectric. Okay, so now the question is, so let us say if I have a capacitor, and let's say these are two plates, and this is, say, plus Q, this is minus Q, right? If I put some dielectric material in between, right, what happens? So now let's first understand what dielectrics are, how they behave when we put them in an electric field. So here what happens here when there are two plates, as an example, if I put some dielectric here in the middle, right, what will happen? So first thing is, let's talk about dielectrics, right? So now there are two kinds of dielectrics, right? So, or two kinds of insulating materials. So one is where, so let us say as an example, you have some molecules. Let's say there are two atoms. Just very simple case. There's two atoms, right? Now these two atoms, they are sharing some electrons, right? That's why they're forming a bond. Now sometimes what happens is one atom is more greedy, right? It's more what we call, so I'll not get into chemistry. Let's say one molecule tends to pull the electrons a little more. So what will happen as a result? If there is a molecule, right? One side of molecule will have slightly negative charge, one will have slightly positive charge, because this molecule is pulling electrons more, right? Now when you have two equal positive negative charges which are displaced by a distance, what do we call them? We call it a dipole. Remember? Dipole. What is dipole? Dipole is nothing but a charge, let us say, minus Q and a charge plus Q, right? And let's say they are separated by some distance d, right? Then we call this a dipole, and just to recollect, there is an associated dipole moment, right? Dipole moment vector, and that is nothing but Q into d, right? So there is a dipole moment vector P, which we define as small p cap, which is equal to Q into d, and this is d vector, where this d vector is taken as the line from the arrow from the negative to the positive charge. Okay. So now what happens normally? Then let's say there is some dielectric material. So I'll just take some material here. Now there are a lot of these, first take a case of polar molecules, right? Polar molecules. What will happen? Now there are these polar molecules which will have different orientation, right? So it's not like all of them, let's say there was one more, right? It would not be like all of them would normally be like plus and minus. They would not be all aligned. So one will be, let us say, one molecule is like this, right? Another is, let's say, like this, right? And so on, right? They would have all kinds of orientations, and on an average they'll all cancel out, right? If you think about the dipole moment vector, let's say there's one dipole moment is like this, another is like this, another is like this, right? So all in different directions, they'll all basically cancel out, right? So overall, if I take any volume, right, and if I look at the total dipole moment, if I added all of them, because they're all kind of in random directions, right, they'll add up to 0. But when I take this thing and put it here in the middle in an electric field, now let's look at this one, right? Now if let's say I apply an electric field, so let's say there is some let's say there is some capacitor here and there is electric field in this direction. This is my direction of electric field. Obviously, it's there inside. I'm not drawing it, just showing from outside. Right? Now, what will happen? Now, this electric field will act on the dipole. Right? So, as an example, this electric field would tend to, if this is the guy, this is the molecule, it will try to, it will pull the negative towards itself and it will pull the positive away and it will cause them to rotate and move a little. Right? And as a result, what will happen? As a result, once you apply the electric field, right, then it will behave, it will be a little more like this. You know, now the direction of these would be, let us say, more aligned. I'm just taking an ideal case. They don't have to be perfectly aligned, as long as there is, on an average, there is some alignment, right? Minus plus, right? Like this. So they are now going to be more aligned, right? Now the question I'm going to pose to you is, right, I wanted to think about this, right? If, let's say, now we have these dipoles which are now, hypothetically they're perfectly aligned, they don't have to be, right, but they're aligned. Now, what will be the impact of that on the electric field? What will be the impact of that on the electric field in the capacitor? So I want you to think about that and then come back and we'll continue the discussion in the coming video, right? Thank you.